Chapter 3 is about to begin. Something that's going to be really helpful for us in 3.1 is Pascal's triangle. So you may remember this, maybe not, from maybe like an intermediate algebra class, or maybe even pre-calc. You might have seen Pascal's triangle. Might have come up in the discussion on sequences and series. Maybe if you didn't, here's the idea. So actually, the triangle that you see here, I've given the first 5 rows. It's actually infinitely big, so you could keep extending it as much as you want. So the idea is it begins with a 1, and then the next row is a 1 and a 1, and they're positioned like this, so it forms that triangle. Then the next row is 1, 2, 1, and you see how it develops. Pascal's triangle, like where do these numbers, it's always ones down the edges of the triangle, but where do the numbers in the middle come from? This 2 you get from the 1 and the 1 in either position above it. So the 1 and the 1 here come together to make the 2. And then this 1 and 2 come together to make the 3. The 3, you see that 6 there in the middle, and the 1 and the 3 and the 4, and so it's nice and symmetrical. And you could keep going down as long as you wanted. So what would the next one be? 1, 5, 10, 10, 5, 1 if you did another. So what's the usefulness of Pascal's triangle? So it turns out it appears in a couple different ways. We're going to see it as the coefficients of the expansion of a binomial. That's really when you first learn it, probably the way you saw it in pre-calc as well. So this one here, think of that as row 0. If you had a plus b raised to the 0, well, that would equal 1. Okay, no big deal. If you have a plus b to the first, well, there's no expansion, right? That's just a plus b. So the coefficients are 1 and 1. 1a plus 1b. I wrote a 2 here, but really I mean a plus b squared. So a plus b squared, if you FOIL that, right, it's a squared plus 2ab plus b squared. So the coefficients are 1, 2, 1. A plus b to the third, has these coefficients 1, 3, 3, 1. We saw that in 2.8 at one point. I believe we had to expand a cube. So it'd be a to the third plus 3. I've actually got it down here. Here's the cube. A to the third plus 3a squared b plus 3ab squared plus b to the third. There's the coefficients 1, 3, 3, 1. And a fourth power would have these coefficients 1, 4, 6, 4, 1. Okay, and you could keep going if you wanted. So Pascal's triangle gives us the coefficients, in this example 1, 3, 3, 1. How do you get the rest of it if you're expanding? So on the first term, you take the first term in here, the a, and you give it all 3 of the powers, right? So your first term would be a to the third. The second one, so it has its coefficient, and then what about the a and the b? So you drop the power of a by 1, and now you increase the power of b by 1. So there weren't any b's, now there's b to the first. Then the next, I know what the coefficient is from the triangle, and the a and the b, well, I know the powers. I drop the power of a by 1, and I keep increasing the power of b. And finally, I've got the 1 coefficient, and now all 3 of the powers, if you will, go to the b. So that's the expansion of a plus b to the third. Okay. I'm going to stop this video here. We're going to get into 3.1 next.